Greetings, math fans. All right, so this is the ACT practice question packet. This has got a lot of problems. Okay, you don't have to go through the whole thing. You can skip anywhere you want in this video and just look to see how I do certain problems. But it's really a good representation of different types of problems that are on the ACT. Now, here's the deal. Make sure you have your graphing calculator when you go to the ACT. You take the test, because a lot of these problems, like simplifying, especially simplifying fractions, you can just do it with your graphing calculator. Why spend all the time doing it by hand when you can use your calculator to do it? Okay, so let's get started. And by the way, the answers to all these problems are in the back of the packet. Okay, so I'm going to try and go through kind of quickly here. Number one for Algebra 1. Basically, it's just using tons of parentheses. I mean, you see you got your brackets here, right? And then you have the square brackets here, and then we have parentheses here. Okay, so you kind of have to work your way from the inside out. I don't have a lot of room here, but basically what I'm going to do is, the thing you got to be careful of is this guy right here. Okay, make sure you do everything inside the parentheses here first, and then you're going to say 2 minus that whole thing. And even this guy right here, that's actually pretty key. You got to do 3 minus 4. So 3 minus 4, negative 1, and then it's 2 minus negative 1, which is 3. And it's going to be 2 minus 3 is negative 1, and 5 minus 1 is 4. Okay. And that does everything inside the inside these guys here. So you get 7, and then basically 2 minus 7 is negative 5. Okay, which is B. Okay, just got to be careful with all that. Now you could put that all in your calculator, and actually that's not a bad thing to do. I know you're looking at the different brackets and everything, but just do a parenthesis here. It doesn't matter. Put a parenthesis here and make this a parenthesis. Okay, as long as you put all the parentheses in there and type it exactly the way it is, you're going to get the right answer. So let your calculator do the work for you. Okay, so for number 2, you can't really just factor this. Maybe you can, it's just kind of difficult. So really what you want to do, again, there's a lot of ways to do these problems, but I would do this. I would say x to negative 2 equals 9. And then in order to get rid of that negative 2 power, you got to raise it to the negative 1/2. Do you agree with that? And because it's x squared, it's plus or minus. So you get x is equal to plus or minus 9 to the negative 1/2 is 1 over the square root of 9, or 1/3. Okay, so that gives you E. All right. And again, I'm going to do these problems certain my way, and there might be a better way to do it or a different way to do it. This is when I just did my work, the sheet here. This is what I came up with. All right, number 3. If A and B are odd integers, which of the following must be an even integer? So I kind of, these are kind of difficult. So what I do for these kind of problems is, like, you can plug in a number. Like if I'm looking for which one's an even integer. So if I do, let's look at number 1 there. If I do 1 plus 3 over 2, that's 4 over 2, which is 2. That's great. But how about 1 plus 5? Let's do the next odd integer. That's 6 over 2, which is 3. So I know this is not a good one. And AB minus 1. Well, again, let's multiply together. So how about 1 times 3 minus 1? So that's 2. How about 1 times 5 minus 1? That's 4. Oh, look at that. 1 times, well, let's do 3 times 7 minus 1. Oh, that's 20. Okay, that looks like a good one. How about AB plus 1 over 2? Let's do 1 times 3 plus 1 over 2. So that's going to be 4 over 2, which is 2. That's good. How about 1 times 5 plus 1 over 2? Well, that's going to be 5 plus 1 is 6 over 2 is 3. Oh, not good. Okay, so that's out of there. So the only one that really works is B. Okay, is that a great way to do it? I don't know. Maybe there's a better way to do it. But, again, if it's going to take you too long to do a problem, you skip it, come back to it. But, plug in numbers. It's not a bad thing. This next one is just recognizing it's 1 over B over 3, the same thing as 3 over B, right? It's just the reciprocal is equal to 1/4. So I cross multiply, I got B is equal to 12. So it's E. Okay. keep going here. Got a lot to do, math fans. Okay, number 5, kind of the same thing. Basically, it's, if I flip it over, it's 2 times 3 over x is equal to 3/7. So it's 6 over x equals 3/7. I cross multiply, so I get 3x equals 42. Divide by 3, and x is 14, which is D. Okay. Number 6, what value must x take in order for the following equation to be true? You're just solving, guys. Cross multiply, right? That's just the easiest way to go. So if I do that, I get 7x plus 35 equals 8x plus 24. So I move that over. I like getting positive values, so I can move the 7x over. I get x equals, and then move this guy over, I get 11. So I get E. Those are easy problems. Got to solve for x for this next one. So basically I multiply by 3/2, so I get x equals 3/2. And then 3/4 plus 3/2. Now again, put in your calculator. Let your calculator do the work. I mean, you could get a comment on this. This is actually pretty easy, but you know, sometimes like why make more work here? 3/2 multiplied the top and bottom by 2 over 2. I get 6 over 4, and so I get 9/4, which is A. Okay, number 8. Basically, I'm giving you values of x and I'm giving you values of y, and you're plugging it in. Another great calculator problem. So, you know, again, I wouldn't write 2 parentheses. Do the multiplication. So it's 1/6 plus, so then it's minus, right? Minus 1/6 minus 2 times 3 times -2. So that gives me -12. So minus 12 over 3 times 3 is 9. 9 minus 4 is 5. So these cancel, and so I have -12/5, which is E. Okay. Number 9. Cross multiply again, right? So 7x plus 42 equals 5x plus 20. And move that over, I get 2x equals -22. So x equals -11, which is A. Got to remember with absolute value, it's 2x minus 5 equals 3, and 2x minus 5 equals -3, right? Plus or minus. Make sure you isolate the absolute value first before you split it up like that. So you get 2x is equal to 8, x equals 4, so 2x equals 2, x equals 1. So 1 or 4, which is D. Okay. Number 11, how many integers are in the solution? You got to remember with absolute value, this is a less than. So it's an and, it's a between problem. So you will need to set this up as this. If it was an or problem, you would say 2x minus 6 is less than 3, or 2x minus 6 is greater than 3 or less than -3. Okay. But anyway, this is a between problem, so we're going to add 6 to all sides. So you get, oops, this is 3 less than 2x less than 9, and then divide by 2. So I'm just going to write this as 1.5 because I'm looking for integers, and that's 4.5. So the number of integers between 1.5 and 4.5 is 2, 3, and 4. So there are 3 of them, so it's D. Okay, number 12, what is the solution to the pair of equations? So basically, you can use your polysimult on your calculator. Okay, it's not a bad way to go. I think that's what I would do to kind of solve it quickly. That's on the website too, on how to use polysimult. So you should definitely learn how to use that and get it on your graphing calculator. But this is a pretty easy problem too, because I can just multiply like this guy by -2. So I get -2x plus 6y equals -2, and 2x plus y equals 2. So the x's cancel, and we get 7y is equal to 0, so y is 0. And then let's plug it into the first equation. So it's x minus 3 times 0, so x equals 1. Okay, so x equals 1, y equals 0, which is A. All right, number 13, at what point do the lines intersect? Well, basically, they intersect when you set them, it's a system of equations. That's what a system is, where the two lines intersect. So basically what I can do is I'm just going to, instead of using elimination method, I'm just going to do substitution. Plug that right into that y. So it's 3 times 7x equals 4x plus 7. So 21x equals 4x plus 7. Move that over. I get 17x equals 7x equals 7 over 17. So, right away, it's one of these two, right? And if I take that, and of course I plug it back into the first equation, so y equals 7 times 7 over 17. So y is equal to 49 over 17. So it's E. Okay, a tricky thing that people do sometimes, it's not, I don't want to even say it's tricky, but you get 1 over 17. I think that's what where this came from, is a 1 over 17. And I'm just subtracting wrong. Let's move on here, but don't make goofy mistakes. All right, number 14. If y equals 3x lies in quadrants 1 and 3, then the absolute value. Well, think about it. Let's graph this real quickly. 3x. Kind of like this, right? And basically what that does is it takes the absolute value. So it takes this part here, which keeps it the same place because it's positive, but it takes this guy here and it draws it up like that. Okay, because it's always positive. So when it hits the 0 point right here, it makes it positive again. So really the quadrants are 1 and 2, which is B. Okay, so next one, just a little exercise in radicals. So radical 16 is 4. That's going to be, radical 12 is 2 root 3, so that's plus 6 root 3 minus 5 root 3. So I get 4 plus root 3, which is A. Okay, 16. Again, you want to be a little careful with, with your parentheses here. It's going to be A. So let's do you want to distribute this negative here to all three. So A plus 2B minus C plus A minus 3B. And A plus 2, let's combine some stuff together now. B minus 3B is negative 2B minus C plus A. And then I distribute the 2, so it's A minus 4B minus 2C plus 2A. And I combine it, so 2A gives me 3A minus 4B minus 2C. Now, of course, they have it kind of mixed up a little bit, too. They got some B's and C's together here. Basically, our answer is E. Okay. 17, find the smallest positive integer, which is divisible by both 12 and 15. Well, this is just kind of going up the way here. I mean, look at it. 36, well, 15 doesn't go into 36. 48, well, 15 doesn't go into 48. 60, oh, yeah. I mean, type in your calculator. 60 divided by 12, 5. 60 divided by 15, 4. That's my answer. Okay? Pretty easy. 18. We're going to cross multiply again. That was really easy. So 3a plus 12 equals 5a plus 10. Move the 3a over, so it gives me 2a. And move that guy over, and gives me a 2, so a is 1, which is B. Okay. And 19. Move it along here. Okay, so if x equals that and a equals negative 2, x equals, well, it's just a matter of plugging it in, guys. So, this is x equals negative 2 minus 3 is negative 5 squared. So x equals 25. Don't forget when you square negative, it becomes positive. And so that's D. pretty easy. Next one, A is 4, B is 7, find the value. So don't try to manipulate it without which is the variables, plug stuff in. So it's 4 plus 4 sevenths over 4 minus 4 sevenths. Okay, and again, I would use a graphing calculator for this one, just because. The key thing you gotta be careful about though is this. Put parentheses around them. Okay, very, very important. So if you put parentheses around them, try on your graphing calculator, you should get D, 4/3. Okay, 21. Again, lots of parentheses. So what I did was, actually to make this a little bit easier, instead of having like a zillion A's in there, I plugged a value in for A. Why not plug a value in for A? And then it's probably not going to work in more than one. It's going to work in the correct one. So if I plug a nice, easy value, and you know what I did is I plugged A, I said A is equal to 1. That got rid of that guy right there. It almost like simplifies it really nicely for me. So if I plug in a 1 into there, I get 1 minus 1, 0. So that's basically, that cancels this out. Okay, and that, so it's basically, I have a 3, so 3 minus 2, 3 minus 2 plus 5. That's kind of what happens when I just stick that A in there, right? It's kind of convenient. So I get 3 minus 2 is 1, 1 plus 5 is 6, so that's 12. So 3 minus 12 is negative 9. So which one of these gives me negative 9? Well, I can see right away if I plug a 1 into here, negative 19 plus 10 gives me negative 9. It works. So the answer to this one is A. And you're like, well, come on, it's got to work at other ones. Boy, you know, it's especially that kind of equation, it's so rare that that number is going to work in another equation. It could, but look at it. I mean, like, B is negative 11 plus 9. It's negative 2. D is 22. C is 20. Or E is 20. Okay? So, you know, it just makes sense sometimes to plug it in. Okay. Okay, so 22. Basically what I would do is just simplify with the parentheses. Okay? So I've got 3s. And you got to be careful with this problem. It's a lot of s's and 5s. They look a lot alike. So 3s minus 5t. I'm distributing that negative with everything. Okay, minus 2s plus 5. So 3s minus 2s is 1s minus 5t plus 5, which is C. Okay, 23, find the solution set of the inequality. It's pretty easy. So 2x, going to add or subtract 5, and divide by 3. Okay, so it's B. Pretty easy. Okay, so next one here. 24. Find x and y which satisfy the following pair of equations. It's a system of equations, guys. Polycymal, man. That's the way I'd go. But let's do it without polycymal here. It's quick. Multiply that by 5. So I get 3x plus 5y is equal to 6. And 10x minus 5y equals 20. So the y's cancel, and you get 13x equals 26. So x is 2, and I'll plug it back into the first equation. So 3 times 2 is 6, plus 5y equals 6. And then I can subtract 6 from both sides, so I get 5y equals 0. So y is 0. So it's A. Which of the following graph is of the equation y equals 2x plus 1? You know, this is pretty easy, I think. First of all, you're looking for a y-intercept of 1, so that means this is out of here and this is out of here. And then you got one more down here too, so there's that guy. But they all have an intercept of 1. Okay, now it's 2x, so it's a positive slope. That means this is a negative slope, so that's out of here. So we're down to 2. We can just eliminate 2 of them so quickly. Okay, it's kind of convenient. And now what you're doing is you're just kind of saying, hey, you got a slope of 2. So it's up 2 and over 1. which you can see is not very good, right? And this one is up 2 and over 1. And so this is your answer, E. Now, the deal with this, too, is you could also plug the point in, 3, 2, and see if it works. And if I plug a 3, 2 into the equation, it doesn't give me the right y. Right? If I plug a 3 into there, I get 2 times 3 is 6, plus 1 is 7. It's wrong. But if I do 1, 3, 2 times 1 is 2, plus 1 is 3, and that works out. Okay? So that's a good way to do it. Okay, let's do number 26. The equation has a y-intercept of, well, that's just really solving for y. I move the x over, so 3y equals x minus 8, and I don't even care about the slope. So y equals negative 1/3 x minus 8/3. So it's C. Okay, not bad. 27, what is the equation of the line which is parallel to that and has a y-intercept of that? So remember, parallel means same slope. So if I solve for y for this guy, I get 3y equals negative 6x plus 4. So y is equal to, divide by 3, negative 2x plus 4/3. So my slope is negative 2, which gets rid of this one and this one, right? Get rid of two equations. And has a y-intercept of 6. So which one or is negative 6? So obviously the one that works here is this guy right here, because it's got a slope of negative 2, y-intercept of negative 6. Okay, really easy. So it's D. Okay, 28. Find the coordinates of the intersection of the following two lines. Again, systems of equations, polysymult. But let's do it real quickly here. I'm going to multiply this guy by negative 2, so I get negative 2x minus 4y equals negative 10, and 2x plus 3y equals 2. That's out of there, and I get negative y equals negative 8, so y equals 8. And then I plug it back. Let's plug it back into that first one here. X plus 2 times y, so x plus 16 equals 5. So x equals negative 11. So negative 11 comma 8. Just do a parenthesis here, so it's B. Okay, not bad. All right, so that was algebra. That was basically algebra 1. Okay, so it should have been pretty easy here. This next is the geometry ACT bank. A little more challenging. Maybe you haven't seen this in a while, so let's go. The diagonal of a square has endpoints 3, 8, and negative 1, 2. What is its area? So what I need to do here, math fans, is this is the diagonal. So what I'm doing is I need to figure out this distance. Because if I get that distance, if you remember, we can use Pythagorean Theorem, but this is x root 2. A lot of ways to look at the problem, but we need to figure out that distance, that diagonal, and then I can figure out what x is. So I'm going to use the distance formula. Those of you who had me, you know the distance formula is a sassy formula, and I say sassy because subtract, add, subtract, sass, subtract, add, subtract, SAS. Okay, so we're going to do the difference of the x's, so 3 and negative 1, and the y's, 8 and 2. So that gives me 4 squared, which is 16, 6 squared, which is 36. So square root of 52. So that's the diagonal. All right, and then that is x root. So again, a lot of ways to do this, but that's x root 2 equals, and we'll do it's square root of 52. Right, so if I divide by the square root of 2, I get x equals 52 divided by 2 is 26. So it's the square root of 26. That's what x is. So if I ask you for the area of the square, it's just 26, root 26 times root 26, which is 26 times root 26, which is 26. That's the area, which is C. Okay? It was a little more involved. The coordinates of the vertices of a right triangle are 1, 3, 5, 3, and 1, 6. Find the slope of its hypotenuse. You know, to me, you got to plot some of these points to see where we're at here, math fans. 1, 3 is here. 5, 3 is here, and 1/6 is like here. So here's your triangle, just to get an idea what it looks like, because you don't know which one you're looking for. And so now it says find the slope of the hypotenuse. Well, if this is 1/6 and this guy here was 5/3, you know your slope is change y over change in x, right? So it's 6 minus 3 over 1 minus 5. So it's 3 over -4 or -3/4, which is A. Okay. Number 3. If point P has coordinates 3, -6, Q has coordinates 5, 15, the coordinates of the midpoint. So guys, this is really easy. Midpoint is literally just the average of the x's and the average of the y's. I know you guys sometimes learn to try to memorize a formula of, y1 plus y2 over 2. Just think, if I asked you what's the midpoint of two tests, what do? You'd add the two tests together and divide by 2. It's the average of them. So that's all you do, math fans. 3 plus 15 over 2, and -6 plus 5 over 2. So 3 plus 15, 18 over 2, 9. -6 plus 5 is -1/2. There you go. So it's A. Pretty easy. 4. A circle whose center is C, -4, 1, pass through the point D, -2, 2. Find the length of the radius. Okay, so if you guys remember the equation for a circle, x minus h squared, I think it's a good idea to know these. Y minus k squared equals r squared. And then what I did is I plugged in, I'm giving you a coordinate, first of all I'm giving you the center, okay, and then I'm giving you a coordinate. So you're basically, the coordinate goes, your coordinate is x, y is -2, 2. And your h and your k are those values. Okay, and that's how we're going to do it, and then we're going to find the value of r. It's really pretty easy. Okay, so it's going to be x is -2 minus h, which is the center, so it's minus a -4, plus y, which is 2, minus, and k is 1. That's what it is. So this is plus. So we wind up getting -2 plus 4 is 2. Squared is 4. That's right, 4. 2 minus 1 is 1. Squared is 1. Okay, so r squared is 5. So r equals √5. Okay, which is C. Okay. Number 5. Some of these get a little tricky in geometry. Square is inscribed, means inside of a circle. The area of the circle is pi. What is the area of the square? Okay, so this is just a little tricky, but you have to realize if the area of the circle is pi, that means pi r squared equals pi. So r squared equals 1, so r equals 1. Don't say plus or minus 1 because there's only a positive radius. So that's what the radius of the circle is. Okay, so that's this distance right here. And I need to figure out the area of the square. So don't you guys agree if I want to go the whole distance here, that's 2? Okay, I need to find the side of a square. Well, remember, it's a 45, 45, 90 triangle. So that's x √2 is 2. And to find out what x is, I divide both sides by √2. So x equals 2 over √2. That's this distance here. Okay, and then now you don't have to rationalize it. And the only reason you don't have to rationalize it is what's squared. Because remember, it's the area of a square is side squared, so x squared. So I square that, and I get 4 over 2, which is 2. So it's the area of the square, D. Okay. All right, next one. Great problem. I love this problem. Okay, so you're given a couple dimensions here, and they're asking you, they're asking you to find the radius of circle A, and they give you a bunch of different dimensions here. Okay, and these are all tangent. So basically what I can do here, math fans, if this is, I'm going to call this x. And that means this side right here is 5 minus x, because the whole thing is 5, so that's going to be 5 minus x. And if that's x, don't you agree that's x too, because it's a radius, and all radii of the same circle are congruent. You learn that in geometry. So this side is 9 minus x. Okay? Well, this is also 5 minus x here, and this is also 9 minus x there, isn't it? Because again, there's one radius and there's another radius of that circle. They're congruent. And here's the radius of that circle and radius of that circle, and they're congruent. So that's why they're both 5 minus x. Well, the beauty of that is this distance right here is 7. So I pretty much can say 5 minus x plus 9 minus x equals 7. Okay, so I get 14 minus 2x equals 7. Negative 2x equals negative 7. X equals 7 halves. Okay? And they're asking, now be careful, because they're asking you what's the radius of circle A. And you know what? People love to do this. They do all this work, and they go, hey, there's the answer. But they're not asking you for what x is. They're asking you what's the radius of circle circle A. Okay? And that's basically 5 minus x, or 5 minus, you can even say 3.5. Which is 1.5 or 3 halves. So my answer is E. Good question. Good question. All right, number 7. A, B, C, D is a parallelogram. AE, they give you distances here. So AE is 7x minus 1. EC is 5x plus 5. Find AC. So we want the whole distance. The thing you got to realize with this one is diagonals of a parallelogram bisect each other. So I know this is equal to this. That's the key to that problem. And it kind of makes sense because you don't have any numbers, other measurements, and so what else are you going to do? You're not going to set it equal to anything. You got to set it equal to itself, right? So 7x minus 1 equals 5x plus 5. Move the 5x over, so I get 2x. Move the negative 1 over, I get 6. X is 3. Okay, so it says find AC. So if I plug a 3 into there, 7 times 3 is 21, minus 1 is 20. Now I could plug it into the other one just to check it. 5 times 3, 15, plus 5 is 20. So my answer, and be careful, right, find A, the whole thing AC, so you double that, and it's 40A. Okay, again, another thing that people do is they go, oh, and they figure out that this is the 20 here, and they circle B. Boo. Okay, number 8. A triangle has angles measuring x, y, and x plus y. The triangle must be... so let's just kind of sketch a picture here real quickly. This is x, this is y, this is x plus y. Okay, so truly what you do is the triangle is 180 degrees in it. And so think of it, isn't it, if I say x plus y plus x plus y equals 180. So I really get 2x plus 2y equals 180. Okay, and the only way this can work is if basically they're going to be the same, right? If x and y are going to be the same. So if I make this 45 degrees and 45, because 90 plus 90 is 180. Okay. Let's see. Let's get another way to look at it. I don't know. I guess I just said this is 90. I kind of investigated this a little bit. 90, 90. This is definitely a tricky question here. Okay, but that's the only way they're going to add up to 180. There might be a better way to do it, but I just kind of look at the problem and say they've got to add to 180, and they have to be the same value, x, y, and x plus y, and the only way you're going to do it is 90, 90, so it's got to be a right triangle. Okay? I think it's, yeah, I'm just trying to look at another way to do it, but I think that's the best way. Okay, let's keep going here. Again, if you find a better way to do it, let me know, and I will incorporate that into my video. Number 9, a square has a diagonal of length r. A second square is twice the area of the first square. What is the perimeter of the second square? Okay, this is a pretty good question here. A square has a diagonal length of r. So this is r. A second square has twice the area of the first. So if this is r, each of these, that's like x root 2 equals r. So each of these sides is going to be r over root 2. Okay, and to find the area of that square, you square this. So you get r squared over 2. That's the area of that square. It says a second square has twice the area of the first square. So if I multiply this by 2, okay, because again, it's the area of the first square, I get r squared. That's the area of the second square. Okay, and so what's each side for that one? Well, if it's r squared, isn't it r and r? So what's a perimeter? Well, they're all r's, so it's 4r. Okay, it's not necessarily an easy way to do it, but it's the way I came up with it. I mean, I just kind of put stuff together and drew pictures. Love drawing pictures because I think it really helps. Unless there's a picture there, draw a picture, especially for geometry. Okay, number 10, in the accompanying figure of a circle centered about point O, the measure of the arc AB is pi over 5 radians. Find OBA. So that angle marked right there. Well, AB is pi over 5 radians, and I would convert that into degrees. I think it just makes sense. So if you guys remember, pi over 5 times 180 over pi, and that gives you 36 degrees. That's what that arc is, 36 degrees. And basically, so this is 36 degrees. So this is what you have. 36. And remember, this is an isosceles triangle. How do you know that? Well, all radii have a circle are congruent. So that means of the same circle are congruent. That means those are equal. So basically you have 180 minus 36, which is 144, left over, divided by 2, which is 72 degrees. Okay, which is D. Okay. Number 11. The ratio of areas of two circles is 25 to 16. What number, when multiplied by the smaller diameter, will give the larger diameter? So what you have is you have pi r squared equals 25 and pi r squared equals 16. Okay, we're talking about a ratio here, so the pi's really don't matter here. I wind up getting, just for comparison, r is 5 and r is 4. We can take the square root. And it says, what number when multiplied by the smaller diameter? Well, I want to convert this in diameters because I have radius right now. So it's going to be d is 10 and d is 8. Okay, and if I say, if I get 10 over 8, I get 5/4. And that's my answer. Okay, so it's a little tricky question. It says the ratio of the area. They give the ratios. What number, when multiplied by the smaller diameter, will give the larger one? So that's what if you multiply that by 5/4, that gives you your large diameter. Okay, can't be reversed because you can't make it smaller, make it 4/5, right? It's 5/4. And sometimes people look at this one and say, well, how about 5/2? But you're not doubling the ratio. The ratio of the radii and the ratio of a diameter are the same. Okay, so you basically keep the you don't double that and make it 5/2. So the answer is A. Number 12, the greatest area that a rectangle whose perimeter is 52 meters can have. Well, the greatest area of a rectangle is a square. Okay, so basically, if that's my perimeter, that means I divide that by 4, and I get 13. That's a side. And to get an area is 13 squared, which is 169, which is B. Okay, 13. The vertices of the triangle are, and they give them to you there. Therefore, it is a what kind of triangle? Again, I think it's helpful to sketch it. Negative 3 zeros here, and 3 zeros here, and 0, 2. I mean, I can pretty much see what it is right away. It's the same distance, right? 3's. So this is definitely an isosceles triangle, B. Okay, now, real quickly, math fans, this is so rare. That is so rare when you see cannot be determined due to insufficient information. I suppose it can happen. I don't know if I've ever seen that come up. Okay, so don't go, oh, it looks complicated. There must not be enough information. Yeah, I don't think I'd answer that one if I had to guess. Okay. All right, number 14. In the above figure, two chords of a circle intersect, making the angle shown. What is the value of x plus y? So it's a little manipulation here, right? This is 30, 50, that's 80, and it's 180 degrees in a triangle. So that means that must be 100, and that must be 100. So that's 200 between those two vertical angles, and it's 360 for a whole triangle. So basically, 360 minus 200 is 160. And that's what we're looking for, x plus y, 160, so it's D. Okay. 15, which are the coordinates of the midpoint M of the segment joining these pair? So again, it's a midpoint formula. It's the average. So 1 plus 5 is 6 over 2. 2 plus 8 is 10 over 2, so it's 3 comma 5. I mean, it's really easy. Okay, 16, in the right triangle ABC to the left, and they give you the different measurements, AC is 10, AB is 12 minus x, and BC is 6. Basically what you're doing here is you're just using Pythagorean Theorem. Okay, so we're going to do basically 6 squared plus 12 minus x squared equals 10 squared. And you just got to kind of multiply it out. So we get 36 plus, I'm not going to do this. I'm going to do that because I could multiply the 12 minus x out. I think it makes it a little more complicated. I'm just going to leave it as 12 minus x quantity squared. I subtract 36 and I wind up getting 12 minus x squared equals 64. Take the square root of both sides, so 12 minus x equals 8, and we'll do plus or minus 8. So I get negative x equals negative 12 plus or minus 8. And the reason I did that is because you can't have a negative value, but there's a negative with that x. So let's just keep that. So negative x equals negative 12 minus 8 is negative 20, and negative x equals negative 12 plus 8 is negative 4. Okay? So we wind up getting x is 20, we get x is 4. Well, think logically. It's impossible for x equal to 20, right? You can't have 12 minus 20. So the 20 is actually out of there. It's not even one of the answers, to be honest with you. But if it was, that would be a bad answer. And so answer is 4, which is D. Okay, 17. In the figure above, AOB is 60 degrees. O is the center. Radius is 6. The area of the shaded region. So basically what I need to do here, math fans, is I need to figure out the area of that whole pi sector there, ABO, and then subtract the triangle. Okay, and that'll give me the area of the shaded region. So the first thing I'm going to do is to find out the whole area of that sector. I know it's going to be, let's see, we know area is pi r squared, but it's 60 over 360, that's the part of it, times pi times 6 squared. So 6 over 360 is 1/6 times pi times 36, which is 6 pi. That's the area of that sector. And I need to subtract the area of the triangle. Well, we know some information about the triangle. First of all, it's 60 degrees. That means this guy's 30. And this is 6. It's a 30-69 triangle. So let's build it up a little bit bigger here. Okay, if that's 30 and this is 6, remember across from the 30 is, that's, if I label this, this is x root 3. Across from the 30 is x. 60, this is actually x root 3. And this is 2x. Okay, so 2x equals 6. So x is 3. So that means this distance here is 3. I guess I'll write that in there. And this is 3 root 3. So going back over to this guy here, if that's 3, that means this whole distance here is 6. And this is 3 root 3. And you know, the reason we need that is because I got to figure out the area. Remember, area is 1/2 base times height of that triangle. Area is equal to 1/2 base times height. Half of 6 is 3. 3. So area comes out to be 9 root 3. So that's the area of the triangle. So it's 6 pi minus 9 root 3. Okay, which is E. Okay, so far so good. Number 18. A rectangular piece of metal has an area of 35 meters squared and a perimeter of 24. Which the following possible dimensions of the piece? It's kind of like you're testing it a little bit. I think the first thing I do is I look at the perimeter. 35 over 2. If I double, so you got to double each, because 35 over 2 by 2, you got to double each of those. Well, 35 over 2, if I double that, I get 35. And my perimeter is 24, so that's impossible. Okay, let's double 5 is 10, double 7 is 14, 10 plus 14 is 24. Oh, that's a good perimeter. And let's multiply 5 times 7, 35. This is my answer. Okay, and you can test, if that happened to be E, you go through a few of them, but, and I think a good way to do it is here. Area is even good too, right? That would work with area. That's 36. That's 32. It's pretty easy to eliminate some of these things. Okay? Number 19. Measurement of ABC is 3 pi over 2. And this is ABC going around this way. That's 3 pi over 2. That means that must be pi over 2. Okay? And pi over 2 is 90 degrees. And if you remember, it's an inscribed angle. This is half of that. So it's half of 90, which is 45, which is E. Okay, when I taught geometry back in the day, I always told the kids, how do you remember that inscribed angle is half of the arc, intercepted arc? I always say, you think of this as your ice cream cone, your ice cream, and this is your cone. Don't you want more ice cream than cone? So the ice cream cone is half of the value of the ice cream, because nobody wants cone. Everyone wants the ice cream. Okay, well, I know some people might like the cone, but you're just a little weird. But that's what it is. Okay. Okay, number 20 is kind of a complicated problem. It's got a lot of stuff in it. Now, if I was taking the ACT and I saw this problem and it had so much stuff to it, I would go back and do this at the end. Okay. Because you don't want to get stuck on a problem and spend like 5 minutes on an ACT problem when you really need to spend 1 minute per problem. If you can come back at the end, that's great, but you don't want to get stuck like missing 5 at the end that maybe a couple of those were easy. All right. Anyway, this is using a little bit of trig here, just some really quick right triangle trig. So let's kind of get going here. We have sine of angle BCD is 1/2. So you got to remember, sine is just a ratio. So sine is opposite over hypotenuse, and again it's a ratio. So it's opposite, which is 1, and hypotenuse, which is 2. Well, obviously this is 8. Well, how do I get 8? just a ratio, so I multiply that by 4. So I'm going to multiply this by 4 as well. So so I don't have too much stuff here, I get this side is 4 and that side, let's get rid of that, that side's 8. Okay, that kind of helps us a little bit. In fact, that gives us a little more information because I have a right triangle here, the 4, 8, and I can just do a little Pythagorean theorem here. Or you could recognize if that's 4 and 8, this is going to be, right, it's probably a 30-degree angle here because that's half of it. So that's 30 degrees. And then across from the 60-degree angle is going to be x root 3. So this is going to be 4 root 3. Now you could have done Pythagorean theorem and that would have gotten you the same thing. Okay? And now you're like, well, how is this going to help us here? We're looking for the ratio of the little triangle to the bigger triangle. Okay, well, I really need to get, I can get the area that this triangle now. That's easy, right? Of BDC, it's 1/2 base times height. What I really need is I need AD. Because I need AD to figure out the area of that triangle. So, one of your properties, if you remember, it's basically a right triangle within a right triangle, is, let's call this, I'm going to do a different color here because it's getting a little messy. Let's call this X. Okay? And if you remember, it's this value, which is 4 over 1 leg equals the other leg, so 4 root 3 over 4. Okay, so the 4 is repeated twice here, that leg. Let's get right here. Okay, so I don't remember that or not. Anyway, cross multiply, I get x, basically 4x root 3 equals 16. And you get x equals, it turns out to be 4 over root 3. Okay? That gives us all the information here. So you basically have to do the ratio now of the little triangle. Okay? So it's going to be, we got to find the area here. Okay, so let's do it here. Let's change my color back to this guy. So it's 1/2, this is from the small triangle. 1/2 base, which is 4 over root 3 times height. And that's going to give us 2 over root 3, so 8 over root 3. And the large is 1/2 base times height, which is going to be 8 root 3. Okay, so it's going to be 8 over root 3 divided by 8 root 3. That's your ratio. Okay, and so let's flip that over again. So this is going to be times 1 over 8 root 3. So the 8's cancel, and we get 1 over root 3 times root 3, so 1 over 3. Whew, that's your ratio, and the answer is E. Oh my gosh. Okay, that took, I mean, you got to kind of know what you're doing here a little bit. It took some time, but you know, if you're going for a 36 in the ACT, you got to get all these questions. If you just want to get into whatever and you just need a 30, I can skip this question and move on to some other questions. Okay? Whew, brutal. Okay. Let's keep going here. We've all survived, I hope. Nobody's sleeping on the computer now. All right. 21. In the figure, BD is parallel to AE. So that's, these guys are parallel. Which of the following must be true? When things are parallel, things are proportional. But let's look at what's going on here. You get CBD is equal to CDB. It doesn't, no, you don't know that. I mean, it looks like it, but parallel lines, mean like that, like this angle right here. Let me do this. Let me erase that. Because it's a little cheesy. This angle is equal to that angle when they're parallel lines. That's all you can say, right? Because they're corresponding angles. But you can't say the other angles are equal. So this is definitely out of here. CAE, so that's this guy. Let me do a different color here. This guy is equal to CEA. No, it's the same thing. Boo, that's out of there. Ratios, CB over CA. So CB over CA is equal to CD over AE. Well, that's pretty random. Okay, so that's out of there. Let's clear everything here. CD over CE. So CD over CE equals BD over AE. Yes, that's good. It's the little triangle over the big triangle is equal to the little triangle over the big triangle. That's a good one. Okay. And then the last one, CB. Let's get rid of that stuff again. CB over BD equals CD over CA. Well, that's pretty random again. Okay, so that's out of there too. So the answer for that one is D. Okay. All right, 22. In the figure, if the square ABCD has a side of length 3, so go ahead and label it. Then the circumference of the circumscribed circle. Circumscribed meaning around, right? It's like the circumference. It's around it. You circumscribe the globe. You go around it. Anyway, then the circumference of the circumscribed circle is. So basically, if that's 3, I need to figure out the radius of the circle. So 3 and 3, and this is 3 root 3, right? Or 3 root 2, sorry. X root 2. So that's the diameter. And the circumference of a circle is pi times diameter. So it's 3 pi root 2, which is E. Okay, pretty easy. 23. It's a good problem here in the figure. AB, the ratio of AB over BD is 1/2. Okay, so you know AB is 2.5. So I can just set up a proportion. So 2.5 over BD, and we'll just call that's this distance here, we'll call that X, is equal to 1/2. Okay, so, it's just, you basically were cross multiplying. So X times 1 is X, 2 times 2.5 is 5. So BD is 5. Is that an answer on there? It's not an answer, which is good, but what happens is people figure that out and they write 5, and that's not right because it's not 5. If that whole distance is 5, they're looking for CD. So 5 minus 3 is 2. So that's my answer, is B. Okay. 24. MNOP is a square with MN equal to X. Then the ratio of the circumference of the circumscribed circle divided by the circumference of the inscribed circle. So what we have here is, if that's X, right? And I need to figure out this distance here, because that's really that's the circumference of the big circle. Okay, so let's do circumference of little is it's pi times diameter. So it's pi x. Okay, and then the big one, remember if this is x, and this is x. It's just a square. So x, and this is x root 2. So that's the circumference of, or that's the diameter of the big circle. So circumference of the big circle is pi root 2x. Okay, and then they say, so the circumscribed is the big one, so it's going to be the big one over the little one. X's cancel, the pi's cancel, and your answer is just root 2, which is B. Okay, 25. AB and CD are parallel. And triangle ACD is the right isosceles triangle. So ACD. So right isosceles triangle, those are congruent. Okay, it's a CD is 6. Let's label here. CD is 6, and AB is 4. What is the area of this triangle right here? So really what we need to do here, math fans, is we need to figure out the area of the trapezoid. It's a right trapezoid, and we need to figure out the area of the right triangle. So trapezoid minus triangle. It's basically what it is. So the triangle is easy. This is 6 as well, right? Because it's isosceles. So area of triangle is 1/2 base times height, which is 18. And then the area of the trapezoid, remember, it's the average of the bases times the height. So 1/2 times 4 plus 6 times the height. So it's 4 plus 6 is 10. Half of 10 is 5. Oh, this would be a 6. And 5 times 6 is 30. So that's the area of the trapezoid. So you basically just have 30 minus 18, which is 12, which is E. Okay. 26. In this figure, CD is parallel to AB. CD over AB is 1/2. So that's a good ratio. Then what is the ratio of the area of CED, the little triangle? So again, it's little, area of the little over area of the big. So this is a little tricky. The way you got to think of this one, math fans, is area is equal to 1/2 base times height. Okay, so the ratio is 1 to 2. So this is 1 to 2, and this is 1 to 2. All right, the 1/2 doesn't matter because it's 1/2 for both the big triangle and little triangle, but the base is 1/2 and the height is 1/2. That's why the ratio is not just 1/2. That would be almost too easy, right? They're not going to give you a really easy problem. So the base is 1/2 of it, and the height is 1/2 of it. And if you multiply 1/2 times 1/2, you get 1/4. And that's why that ratio is B, 1/4. Okay, a little tricky. All right, 27. In the figure, AC is equal to CB, so these are all equal. Then theta equals. Just got to work your way around here, math fans. Okay. First of all, that whole thing is 80 degrees, and that guy is 50. So, and this is an isosceles triangle. So, if that's 50, that means that's also 50. So that's 50 degrees, and that means that's 30. And remember, same thing here. If that's 30, that's also 30. So if those two are 30, that's 60. That would make that 120. That angle right there, this angle right there. Okay. And so that's 50 and 50. It's 100. That means that is going to be 80 degrees. This angle right here. So we got 120. We got 80. It's 200 degrees, and this is left over. We use a different color. That's what we're looking for. So it's basically 360 minus 120 minus 80. So 360 minus 200 is 160, which is C. Okay. 28. AB is the diameter of circle C, and sine of x is 1/3. Evaluate sine of y. Okay, so remember, these are all ratios. That's all it is. So let's kind of mark things out here. If sine of x is 1/3, and definitely this is a right triangle, and you're saying, well, how do you know this is a right triangle? That's a diameter. It's an inscribed angle. So if this distance here, if that's a diameter and this is 180 degrees, that angle, the cone, is half of that, which is 90 degrees. Okay? So anyway, sine of x is 1/3, so it's 1/3. Okay? And basically, you can use a little Pythagorean theorem here, and it's basically saying whatever, or this value here, we'll call this little b. So a squared plus b squared, so it's 1 squared plus b squared equals 3 squared. So b squared equals 9 minus 1 is 8. So b is equal to 2 root 2. Okay? And then they say evaluate sine of y. That's really easy. So sine of y is opposite, so it's 2 root 2 over hypotenuse. So 2 root 2 over 3, which is C. Okay, that's it with geometry. Good old geometry. All right, now we have algebra 2. A little bit more challenging than the algebra 1 problems, but it is what it is. If the cost of a box of pens, 12 pens is $7.20, and a box of 16 pencils is $4, what is the cost of 3 pens and 3 pencils? That's easy. I mean, if you think this is hard, then you might want to cry right now. All right, it's $7.20 divided by 12. So it's 60 cents for a pen. And 16 pencils cost $4. So if I divide that, I get that's 25 cents. So it's 3 times 60 cents plus 3 times 25 cents. Woo! Rough one. Okay, and it's $2.55, which is B. Okay, number 2, find all roots of that equation. Well, this one's already factored nicely for you, so you know x equals -1. That's pretty nice. And you just got to factor that guy. So x plus 5, x minus 1. So x, and that's equal to 0. So x equals -5, x equals 1. So it's -1, 1, and -5, which is C. Okay, 3. If f of x is that and x is between 3 and 5, then f of x, well, it's just you plug it in. That's easy. You plug a 3. 3 times 3 is 9, plus 5 is 14. And you plug a 5 in there. 15 plus 5 is 20. So it's between 14 and 20, which is C. Okay, you know, it looks a little nasty. Simplify it, but again, you just got to watch your parentheses. Make sure you distribute negatives. So it's 8x squared minus, let's just keep that together here. 7x, so minus x squared plus x minus 5y. And that closes that, and then it's plus 2x minus 3y. Okay? So I would now distribute that. 8x squared minus 7x plus x squared. I could have added the x's together, but that's okay. Minus x plus 5y plus 2x minus 3y. So it gives me 8x squared. Cross that out. Negative 7x minus 6, negative 8x. Plus 2x is negative 6x. Oh, I have 8x squared plus 1x squared. This is 9x squared. Okay, so that gives rid of that, that, and that. And then 5y minus 3y is plus 2y. So it's 9x squared minus 6x plus 2y, which is a. Now here's the deal. If you make a really goofy mistake, like just not like how I forgot to add these two guys together here, it's not going to be one of the answers. Okay. Now if there's none of the above, then you're kind of in trouble because you might put that, but none of the above is not really used that much either. But you never know. Okay. The fraction blah blah maybe expressed more compactly as, well, what I would do, I kind of recognize this, I can factor that. So I would say 2 over b squared a squared times the reciprocal. I'm going to factor b out of there. So b minus 2 over 1. So that crosses off with that. And I get, none of these have parentheses, so I'm going to distribute that 2b minus 4 over b a squared, which is e. Okay. Number 6. Xy is not equal to 0, then I don't know how you guys learn simplifying fractions, but you need to multiply by a common denominator, and this one happens to be x squared y squared. So I'm going to multiply everything by x squared y squared. So I multiply this guy by x squared y squared. I get x y squared. Multiply this one minus x squared y. This one I get y squared. This one I get minus x squared. All right. Got to simplify more, but I can see I can factor. So on the top, I can factor an xy out. And I get y minus x. And on the bottom, it's a difference of 2 squared. So y minus x. Woo, how nice. Y plus x. That cancels. So I get xy over x plus y, which is a. Okay, kind of nice. Okay, let's keep going here. Number 7, the solution set. I'm just going to cross multiply here, math fans. That's all you do. So basically you get x squared plus 8x plus 23 equals 7. So it's really x squared plus 8x plus 16 equals 0. And I factor that, I get x plus 4, x plus 4. So x equals negative 4, which is C. Okay, number 8, a over b is 4. What is a squared minus 16b squared? Basically what you need to do here is you need to solve for one of the variables. Okay, to figure out a is, and then do a substitution. So what I'm going to do is I'm going to cross multiply here. So I get basically a is equal to 4b. And then I'm going to plug that into here. I'm going to plug 4b into here. You can see you get 4b quantity squared minus 16b squared. Well, that's 16b squared. That's the only reason I have an answer here, is because it cancels out. Otherwise I couldn't do it. I would have an a or b left over. So my answer is C0. Okay. Number 9. ABC multiplied is not equal to 0. Then what is that equal to? So this is just a matter of simplifying. You really need to simplify this guy right here. So it's 3b cubed a squared over 33 a cubed. It's b to the 6th, and this is a b to the 4th. So it's b to the 10th and c to the 4th. So basically I get 1/11. The bottom b wins, so it's got, well, let's do the a first. Do you guys agree this is a on the bottom? It's b to the 7th on the bottom and c to the 4th on the bottom. And that's your answer. Okay, so that gives me D. Next one, you got to get a common base. So that 16 is really 2 to the 4th power. So it's 2 to the 6x minus 8 equals 2 to the 4th. Once you have the same base, you can just set the exponents equal to each other. So 6x minus 8 is equal to 4. 6x equals 12. X is 2. So it's A. Okay, number 11. This one's a little tricky. F of x equals x plus 1, g of x equals 2x minus 3. And operation star is defined for all real numbers a and b by the equation a star b equals 2a plus b minus ab. Then f of 3 times g of 4. You're basically, what you're doing here is you got to figure out kind of what, well, you know what this means. This means, when you multiply, it means this. So f of 3, that's kind of like your a, and this is like your b. And so you're going to, here's your a. It's 2 times f of 3, right? Plus, and then your b, plus g of 4 minus f of 3 times g of 4. So that's what it is. The f of 3 is your a, and g of 4 is your b. Okay, so you got 2 times f of 3 is 3 plus 1 is 4, plus g of 4, which is 8 minus 3 is 5, minus 4 times 5. So we have 8 plus 5 minus 20. So 13 minus 20 is negative 7, which is B. Okay. This guy right here, you're definitely going to have to write as multiplication and then your factor. So it's 2x minus 4 over x plus 1. That's x squared on minus 1 on top, so it's x plus 1, x minus 1. And the bottom, I can factor out a 3x, and I get x minus 4. So x minus 4's cancel, x plus 1's cancel, and I have 2x minus 1 over 3x. Okay, which is D. Okay, 13. I would definitely review log properties for the ACT. Definitely. Okay, what you're trying to do here is you're trying to condense it into have a log on one side and a log on the other. Because once you do that, you get one log on either side. You can just set those values equal to each other. It's kind of nice. So I'm going to move that 2 to the top here. So I get basically log of 2 plus log of x squared equals log of 4x minus 2. And then this is addition, so it's really multiplication. So it's log of 2x squared equals log of 4x minus 2. And now I can set them equal to each other. So 2x squared equals 4x minus 2. Move it over, so 2x squared minus 4x plus 2 equals 0. If you want, I think it's nice to take a 2 out of there. So just gives me x squared minus 2x plus 1. And that factors to x minus 1. X minus 1. So x equals 1. Okay? And that is D. Okay, 14. A is negative 1. So let's just plug it in. It's x to the negative 2, so it was 1 over x squared. And A is negative 1. It's 1 over 2x. Okay, please don't make a number negative. It's the fraction flips. Okay, if I cross multiply, I get x squared equals 2x, and I can do this: x squared minus 2x equals 0. Factor out an x. So I get x equals 0, x equals 2. But x can't be 0. Because that would be undefined and that would be undefined. So the only answer is 2. That's why you look at it and you go, oh, gee, 0. And they could have had 0 and 2, but in this case here it's just 2, which is D. Okay, number 15 is actually it's a really good problem. The reason it's a really good problem is because you have to kind of think a little bit when you're doing the problem. basically that solution's got to be greater than 0. So here's the deal. The top and the bottom both have to be positive, or the top and the bottom both have to be negative. Okay? That's what makes it a good problem, because you kind of have to think of both things here. So let's get two scenarios. I almost need a little bit more room here, so I'm going to kind of just go a little bit on top. I'll put the first, I cleared a couple things out here. Let's do positive over positive. Okay, so I'm going to do 2x plus 1 is to be greater than 0. So basically you get x is greater than negative 1/2. And x squared minus 4 has to be greater than 0. So if I factor that just to get my solution, x minus 2, x plus 2. So my critical points are 2 and negative 2. So if I do my interval testing, I get to be greater than 0, it has to be greater than 2 or less than negative 2. So both of these have to be true. So that has to be true. And here, let's graph this guy right here. So both 2x plus 1 and the x squared minus 4, they both have to be greater than 0. And if you look where they're both greater than 0, it's from right here out. Okay, you guys agree with that? So it's kind of a good problem. So basically you're saying x is got to be greater than 2. That's when they're both positive. Let's look when they're both, it's negative over negative. So it's the same thing. 2x plus 1 is less than 0, so x is less than negative 1/2. And x squared minus 4 is less than 0. So it's the exact same thing, math fans, except it's between these two values. And it's less than negative 1/2. So this is negative 1/2. And it's less than negative 1/2. So the overlap of this is really between those two values right there, which means x is between negative 2 and negative 1/2. Okay, so that's actually my solution, and the answer to this one is D. That's got everything. X is greater than 2, or x is between negative 2 and negative 1/2. Not necessarily an easy problem. That's a really good problem. Okay. All right, 16. In which quadrants does the solution lie? So you kind of need to make a quick sketch here. 1, 2, 3, and it's negative x, right? So basically, this is what you're going through here. Sorry. Okay, and it's less than, so it's below it. And then this guy is negative 3, and then it's up 1 over 1, so it's actually going through there. Technically, these are supposed to be dotted lines. Okay, I just drew solid just because, just kind of doing it, but they should be dotted lines. Okay, and that's below it as well. Okay, so again, I keep going here. So really what you see is it's nothing in this quadrant. It's nothing in the first quadrant. It's nothing in the second quadrant. It's either in the third quadrant here or fourth quadrant here, and it's also in this quadrant here, even though it doesn't really show very well. So it's quadrant 3 and 4, which is A. Okay. So far so good. We're getting there, math fans. In the system, that looks really complicated, but they're giving you x and y, and they're asking you to find a and b. So just, you can plug it in. So x is 2, so you basically get 2a plus b equals 20, and 2b plus a is equal to 16. Now, I'm going to write this as a plus 2b equals 16. I don't like it written that way because I like things to line up. So I'm going to multiply this one by negative 2. Again, polysimul, I would use that. I would not be working on systems of equations. But this is easy. It's probably for just as fast. Anything bigger than that, you want to use your calculator. Anyway, you get 2a plus b equals 20, and negative 2a minus 4b equals negative 32. So it gives me negative 3b equals negative 12, so b is 4. And then plug that into, doesn't matter, the second one here. So we get a plus 8 equals 16, so a is equal to 8. So 8 and 4, so the answer is C. Okay, number 18. These are just knowing properties as opposed to a problem. So what I would do is I think I would know my properties of circles, ellipses, hyperbolas, and parabolas. I mean, parallel lines is part of a geometry thing. I would know my properties. I would know how to find the foci, the major minor axes, how to find the center, the vertices. I just think that would be a good thing to know that. But it says the set of points with the property that the distances from each point to two fixed points has a constant difference it's actually a hyperbola. Okay, look it up on the web a little bit if you want, and there's some good pictures out there, but just know your properties. Okay, 19, A is between 5 and 8, B is between 6 and 9, then AB, well, again, this is really easy, right? Just multiply it. So 5 times 6 is 30, and 9 times 8 is 72. So the answer is C. Okay, this one, great calculator problem. I don't know why you not use your calculator. The only thing you got to be careful of is your parentheses. So definitely parentheses here and definitely parentheses here. But not using a calculator, I'm going to multiply it by our common denominator, which actually is, everything goes into 12. So 12 over 12. And look how easy this is going to become. 2/3 times 12, that the 3 and the 12 cancel. It's basically you get 8. 4 times 2 is 8. 1/2 times 12, so 6. The bottom, 3/4 times 12, that gives me 9. 1/3 times 12 is 4. So 8 plus 6, 14 fifths, which is B. Okay? If A plus 1 over A is equal to 2, then A is equal to, well, what do you want to do here? I'd get it for fractions. So I'd multiply this whole thing. Though you're adding an extra variable, I'd multiply it by A. That gives you A squared plus 1 equals 2A. So A squared minus 2A plus 1 equals 0. Factor that. I get A minus 1, A minus 1. So A is equal to 1. Okay? And, I multiply by A. So you want to check for extraneous solutions. You want to see if the 1 works in there. So it's 1 plus 1 is 2. So that's good. So we got C as our answer. Okay, 22. If 2/3 A equals 2, then A minus 2/3. That's really easy. Multiply this by 3/2, right? 3/2. And so I get A is equal to 3. So then I have 3 minus 2/3, which is 2 1/3, or 7/3, which is D. All right. 23. If x and y are positive integers, which of the following must be a positive integer? Kind of the same thing as we did like early in this worksheet here. Pick some positive integers. Just see which one works, right? I mean, well, and this kind of, I think this is a little logical here too, right? Obviously, if they're both positive integers, isn't this one going to be good? Of course it is, because they're both positive. You're adding them together, they're going to be positive. This one, not necessarily true. 3 minus 4, negative. So that's out of there. Two numbers multiplied together, are they going to be positive? Yep. So that's 1 and 3, which is D. That's really easy. If 9 minus k and 17 minus k have equal but opposite signs, and k equals, so they're not. If they were equal, you set them equal, but they're equal but opposite signs. So put a negative in front of it. So 9 minus k equals negative 17 plus k. So if I add k to both sides, I get 2k over here. Add 17, I get 26. So k is equal to 13, which is B. Okay, 25, x equals root 3, y equals root 2. This is easy. So it's 2 root 3 plus 3 root 2 times root 3 plus root 2. And now it's FOIL. So 2 root 3 times root 3 is 6. Outside plus 2 root 6. Inside plus 3 root 6. And last plus 3 times 2 is 6. 6 plus 6, 12. Plus 5 root 6, which is E. Find the solution set of absolute value of x plus 2 over x minus 1. Basically what I can do with this one is that x plus 2 can be positive or that x plus 2 can be negative. So let's set up two different problems. So it's x plus 2 over x minus 1 equals 3 over 1. So I cross multiply, I get 3x minus 3 equals x plus 2. So I get 2x is equal to 5, so x is 5 halves. And then let's do a negative x plus 2 over x minus 1. So I cross multiply, I get 3x minus 1, or minus 3, sorry, equals negative x minus 2. So move that over, I get 4x is equal to 1x is 1/4. So 1/4 and 5 halves, which is A. Okay, 27, perform the indicated operation. A lot of factoring here, math fans. I'm going to factor 3 out of the top. So 3a minus 3b over x minus 5 times, I'm going to factor out a y, x minus 5. At the bottom, I'm going to factor out an x. So a minus 3b. So a minus 3b cancels. X minus 5 cancels, and I get 3y over x, which is B. Okay, and 28. Which equation expresses the relationship that the height varies inversely? Inversely means just the reciprocal as the square of the base. Okay, and that's, so again, the height varies inversely to the square of the base. So let's see. All right. Combine these guys together, so we need a common denominator. So I'm going to multiply this by a plus b over a plus b. Okay, and if I do that, I'm going to FOIL the top. So I get a squared plus 2ab plus b squared minus 2ab. The whole thing's over a plus b. Okay, the 2ab's cancel. That's kind of nice. And I have a squared plus b squared over a plus b is E. Please don't think you can cancel it out and write a plus b, even though it's not on here. Okay, but people sometimes do that. Okay, 30. Basically, you're writing it as an exponential here, math fans. So it's 3 to the second power is equal to x plus 7. It's really easy. So 9 equals x plus 7. So x equals 2b. This one is, you can take the log of both sides. And then the x goes in front then. So you get x log of 10 equals log of 31.4 and divide by log of 10. And then that's your answer, which actually comes out to be 1.5. But you can also look at it logically. I think if I was doing the problem, I'd look at it and go, well, 10 to the 0 is 1, 10 to the 1 is 10, 10 to the third is 1,000, and 10 to the 31.4 is huge. So it's got to be this one. And plug in your calculator, 10 to the 1.5, and you get 31.4. Okay, C. This one, it looks like they're trying to get a common base. So what we're going to do is going to 2 to the 4x. 8 is 2 cubed and 2x. So you're basically, as long as you have the same base, you add. So this is a 6x here, right? And 4x plus 6x is 10x. So 2 to the 10x, which is B. Same idea. We need a common base. So 64 is actually 2 to the 6th. Once you have the same base, you can just set the exponents equal to each other. So we get C. Okay, 34, consider the graph below. It represents which one? You know what? You could use your graphing calculator. You could think a little logically. This is definitely a rational function. And there's an asymptote at 0, at x equals 0. Okay? That would pretty much eliminate this one because that's a quadratic. This is a log. A log looks like this. You should know that. That's an exponential. An exponential looks like this. So that's out of there. So you kind of wind up with those two. Can't be x squared because nothing could be negative. X squared actually would look more like this. Okay? So it can't be that one, so that's my only possibility. And you can graph it quickly, and you see it is 2 over x. Okay, keep going here. Consider this function. It looks a little nasty, and it looks like you want to do a little bit of work on it, but it's actually not that bad. If I'm asking you, this is the inverse of the function. Inverse, if you guys remember from Algebra 2, you would always swap the y and the x. Okay, which means it's symmetric about y equals x. So here's y equals x. Just going to draw them in here. Okay, let's look at this guy right here. If it's symmetric about y equals x, isn't it this? Hey, that's my answer. Okay, D. Okay, f of x is that, and the domain is between that, and the range is, you just plug it in. It's really easy. If I give you the domain, you plug it in to find out the range. So it's negative 5 over 5 is negative 1, minus 3 is negative 4. 15 over 5 is 3, 3 minus 3 is 0. So it's between negative 4 and 0, which is E. And 37, they ask you if f of x is 3x plus 4 and the slope of f of x plus 3. So f of x plus 3, which is you put a x plus 3 wherever you see an x. That's all you do. And then if I simplify that, I get 3x plus 9 plus 4. I don't even need to add those together because I'm not even concerned with that. My slope is 3. A. Oh yeah. All right. We're getting there, math fans. We have one last topic here. It's trig. Some of you watching the video may have seen trig. If not, you're not going to learn for ACT if you're taking the ACT just before you took the trig class. I mean, it's an entire semester's worth of material, but you know, maybe hopefully you'll learn the basic right triangle trig because that's most of the time what it's all about. Okay. For the triangle below, determine sine of 2a. Now, what you need to know for this, first of all, this little angle here is just angle A. It's not a right angle, so it's right angle. Or it's angle A. Sine of A, it's a double angle. Okay, if you don't, again, I'm assuming you know trig. If you know trig, you're following along here. It's 2 sine of A cosine of A. That's what that double angle is. So I know sine of A. Well, here, I got to do one thing here first. I'm going to drop down. I need a right triangle because that's you need a ratio here. So I have a right triangle. So that's 2 and 2, and that's 2 root 3. That means each of these are root 3, and this is root 3. Okay, that kind of helps a little bit. And if that's 2 and that's root 3, this is a 30, 60, 90 triangle. Across from the 60 is that, and across from the 30 is that. So this is going to be a 1 then, right? Half of that across from the 90. So that's my angle. And that actually is kind of nice now, because now I say sine of 2a, I'm going to use that triangle I just drew here, that right triangle. So sine of 2a is 2. Sine of a is opposite over hypotenuse. Cosine of 2a is adjacent, which is root 3 over 2. So I multiply that out. I wound up getting root 3 over 2, which is e. Okay, not bad. The product, basically what you're doing is you're writing everything in terms of sines and cosine. So you have sine, you have cosine, you have sine over cosine, you have 1 over cosine, and cosine over sine. And let's see, we can cancel cosines out here. There's a sine, that's a cosine, and what's left over? A sine. So the answer is A. Which of the following is a sketch of absolute value of sine of x? This is impossible because negative and it's negative, so these are out of here. And this is out of here. That's a negative. Okay, so look at the next one. Remember, sine starts at 0. This is a cosine graph, actually. So that's out of here. So my answer is C. It's the McDonald's graph. Okay, number 4. For the following sequence of numbers, the next number will be, this was kind of tricky. I kind of had to think about this one for a while. I'm like, what the heck is the pattern? Well, it's not a geometric or an arithmetic, if you know what I'm talking about. So if I find the difference, let's ignore the 1 for now. The difference between 2 and 12 is 10. The difference between 12 and 30 is 18. And the difference between 10 and 8 is 8. So if I would say the difference between 10 and 18 is 8, and I would add another 8 to this, I'd get 26. Right? And the difference between, so then if I add 26 to that, I get 56. That's kind of a weird way to look at it, but it's looking for an explicit formula. It's just kind of it's a difficult problem. I mean, you can kind of be a little logical, and you definitely know it's not 1 over 27. You can knock that one out right away, right? And it looks like it's getting bigger. If you're going 2 to 12 and 12 to 30, it's getting to be bigger. So the 48, well, 36 is probably out of there. Anyway, it does come out to be D. Okay. Given 2 tangent squared of x plus secant squared of x equals 2, what is tangent of x? What you need to know for this one, math fans, is one of the identities. Tangent squared of x plus 1 equals secant squared of x. So let's substitute that in there for secant squared of x. So it's 2 tangent squared of x plus tangent squared of x plus 1 equals 2. So 3 tangent squared of x equals 1. Divide by 3, so tangent squared of x equals 1/3. And I'm looking for tangent of x, so it's the square root of that. So tangent of x equals plus or minus root 1/3, or 1 over root 3, okay, which is C. Okay, 6. If uv is equal to pi over 2, find the value of sine of u squared plus sine of v, or sine squared of v. Basically what I am going to do here is, since these have to be 90 degrees, couple ways we can do that. First of all, you just use the ratios. So I think that's probably the easiest way to go here. So if I said sine squared of u, remember it's opposite over hypotenuse. So opposite over hypotenuse squared plus sine of v, opposite over hypotenuse. Okay? So they give me a squared over c squared plus b squared over c squared. And so I can do this, right, get rid of that. So it's a squared plus b squared. What's a squared plus b squared? C squared. So c squared over c squared is 1. B. Now I could have done that one just, if you know some values, I could put 45 degrees in each one of those because it doesn't matter. Right, I could have put 45 degrees here. And I could have found the sine of that, which is root 2 over 2 squared plus sine of that. So that's 2/4 plus 2/4, which is 1. Okay. All right, last one, math fans. Woo! Okay, use diagrams below to find the value of cosine of 1/12 pi. In order to do this one, you got to know some difference for cosine. Cosine of pi over 12, because I'm given pi over 4s and pi over 6s and pi over 3s, one of them is pi over 3 minus pi over 4. Because that's really saying 4 pi over 12 minus 3 pi over 12, which is 1 pi over 12. And so you got to know cosine of basically a minus b is cosine of a, cosine of b, plus sine of a, sine of b. Okay? And so let's do cosine, we'll call this has got to be a, because that's my pi over 3, and this is my b. So cosine of a is 1/2. Cosine of, and when I say cosine of a, that's pi over 3. So let's ignore that. It's pi over 3. So it's adjacent. Let me put the 1 here. It's a little cleaner. Adjacent over hypotenuse. Cosine of b is adjacent over hypotenuse, so 1 over root 2. Plus sine of a, root 3 over 2. And sine of b, which is 1 over root 2. Okay, so I think the hardest part of solving this one is actually simplifying it enough to give you, what you want here, one of these answers. I'm going to rationalize that too, so let me just do that. 1/2 root 2 over 2 plus rationalize that gives me root 6 over 2. So it's root 2 over 4 plus that's over 4, root 6 over 4. So it's kind of looking like it's going to be a, math fans, because I can factor out a root 2 over 4. Root 2 over 4. If I factor that out, I get 1, and I get root plus root 3. I mean, so you can even see if you distribute that back, you'd get the same thing that we had here. Okay, so the answer to this one is A. Okay, that's the end of the video. It's about a 2-hour video to go through this whole thing, but hopefully this has helped you guys, with some of these problems. And there's so many more ACT practice problems out there, but it's just a small sample of it. But hopefully it helped you guys out. All right, that's it, math fans. 2 hours. It's a long time. Have an outstanding day. Adios. Goodbye.